All right, today we're going to talk about 2-2, which is complements, subsets, and Venn diagrams. So the set of all elements being considered in a given discussion or problem is called the universe set. So the universe set is denoted by U. So the complement of a set, so here, set A, it's going to be denoted by A prime, so the little tick mark. It's the set of all elements in the universe that are not in A. So if I'm looking at this picture here, here's my universe, here's A. So A prime, or the complement of A, is everything else on the outside of A. So here, it's just denoting it using our set builder notation. So it's X such that X is in the universe and X is not an element of A. So this first example just wants us to find the complement of A. So it equals, I would go ahead and just cross off anything that's in A in my universe and write everything else. So since 1 is in A, I cross it off. 3 was in A, 4 is in A, 7's in A. So I'm left with everything else. So 2, 5, 6, 8, and 9 would be the complement of A. So a subset, set A is a subset of B, and it's denoted with the side of AU with a line under it. So A is a subset of B if and only if every element of A is also in B. So in this picture, A is a subset of B if all of A is inside my B. So here, A is going to be a subset of A for any set A, and also an empty set is going to be a subset of A. So this one just says if B is a set of even numbers, A is the subset, or is the set multiples of 4, then A is inside of B. So A is a subset of B because 4 is an even number, 8 is an even number, so on. So here, it just wants us to determine if each of these is a true or false statement. So is 1, 3, 5 a subset of 1, 5, and 9? Well, since 3 is here, but it's not in this one, that would be false. I'll just write 3. This one says the whole numbers is a subset of my natural numbers. Now, that is also false because our whole numbers, like we talked about in 2-1, include 0, but natural numbers do not. C says our integers is a subset of our rational numbers. Well, all integers can be rewritten as fractions, which would make them rational numbers. So this would be true. D, my empty set is a subset of the universe. Well, that's true because any empty set would be a subset of any universe. And the next one says -6, 0, and 11 is a subset of my integers. All of those are integers, so that is true. Next it says what set is represented by A prime prime. So the A complement, and I'm taking the complement again. Well, if I'm taking the complement of something that's not A, I would be left with A. A proper subset is going to be denoted with just the U. This time you drop the line under it. So this is if every element in A is inside of B, but they're not the same exact set. So there has to be a little bit of a difference. So B has to have a little bit more in it than A would, but all of A has to be in B. So here it says that the natural numbers is going to be a subset, a proper subset of our integers. So are all natural numbers integers? Yes. And then are there integers that aren't natural? Yes. So they're not equal, but they are, but all natural numbers are contained in integers. So determine whether the first one is, this one would be yes. The next one says, are all natural numbers a proper subset of the whole numbers? So are all of our natural numbers whole numbers? Yes. And then are there any whole numbers that aren't natural? The answer would be yes. It's 0. So this is yes. C says, are all prime numbers odd numbers? That's no, because 2 is prime, but it's not odd. D says, are all multiples of 2 even numbers? Yes. And then, are all even numbers multiples of 2? That answer is yes. So since they're the same exact set, this would be no, it's not a proper subset. So this next part wants us to list all the subsets of A, B, C, D, E. So when I go to list this, first I would have my empty set. Then I could have all sets of one letter. I didn't mean to put that comma. So I could have A, I could have B by itself, I could have C by itself, D by itself, and E by itself. Then I can have all sets of 2. So I could have AB, I could have A with C, I could have A with D, I could have A with E. Next, I can end up having, I could start with B. I already have B with A, so I can have BC. I could have BD. I could have BE. That's all the ones that start with E. Then I could have C with D, C with E, and then I could have D with E. So that's all my subsets there. So next, I could have sets of 3. So I could have ABC. I could have ABD. I could have ABE. That's all the ones I could start with AB. So I could have ACD. I could have ACE. I could have ADE. Then I could start with B. I could have BCT. I could have BCE. I could have BD. I could have CDE. So that gave me 10 sets there. So then I can move on to my sets of 4. I could have A, B, C, D. I could have A, B, C, E. I could have A, C, D, E. I could have B, C, D, E. And I could have A, B, D, E. I forgot that one. And then the last one would be the set of all 5. So it's just the original set we had. A, B, C, D, E. Now for this one, it actually kind of turns out nice because I had one empty set, one set of 5. I had 5 sets of 4, 5 sets of 1. And then I had 10 sets of both of those. My 2 and my 3. Now, on the back, it's going to talk about a shortcut that I could have done to figure out how many sets. Now, this was to list them all out. Now, to figure out how many sets, the set, we're not going to talk about the paradox. The set with n elements has 2 to the n subsets. So what that means is for that last one I just did, if I wanted to figure out the number of subsets without having to list them, I would take 2 to the power of how many elements there are. Well, there's 1, 2, 3, 4, 5. So 2 to the 5th power is going to get me that there are 32 sets, because I take 2 times itself 5 times. And then to double check, well, 1 plus 5 is 6, plus 10 is 16, then I got 26, 31, 32. So I listed all 32 of the subsets, and that is it for the 3-2 notes.